Hello, and today I'm going to be doing a video on the TI-84 Plus AP Chem Calculator Guide. This is a crucial part in AP Chemistry to solve problems of all types. So we're going to be covering a couple programs and apps that you can use to help you in AP Chem. The first thing, and probably one of the most important, is the periodic table. This will be found in the Applications button here. Scroll down all the way down to number 8. And it'll pull up this interactive app that has the entire periodic table with the atomic numbers. And you can go to zoom here to go into the list to find it all in numerical order. From here, you can sort it based off of the atomic number, name, or symbol. So for example, this will just go in alphabetical order based off of the symbol. Here is the most important function is if you go into options, you can find under graph properties, you can find all of these periodic trends, which are very important in AP Chemistry. Atomic radius will tell you how large the atom is, so you can see all these going up with hydrogen being the smallest, and it just continues to go bigger and bigger, following the periodic trend that we all know and love. You can also go into first ionization energy, which will show you how hard or how many joules it'll take to remove the last electron in a element. This is very useful for the AP tests, which I just took, and I had to use this application a lot. Same thing with electronegativity, density, and melting point. These all have the same things, just a graph showing how dense or electronegative a element is. From here, we can quit out and go into programs, which will be for all calculations. The first thing will be Atomics Lab, which has a generalized list of everything for AP Chem. So this you can find the constants for equilibrium. So we'll just go into here, K equation solver, and this will be the calculation that you have to do to find K. So this will be on your reference sheet. You can plug in all these numbers. A, we'll just say is 8. The coefficient will be 1. 2, we'll say is 6. Coefficient will be 2. And all I'll do is just plug these numbers in to give you an answer. So then you can see that is going to be 0.25. So this is a very helpful application if you're trying to solve for equilibrium. From there you can just hit enter to go out. Then you have the Pivnert for pressure, but we can get into that a little bit later. Gibbs free energy, which is also another program that we can go more in depth in later because we have a separate program for that. pH solver, which is going to just essentially help you solve for pH. So you either have the concentration of the ions or the actual pH, and we'll just say is 3.0 to the -3rd power, and that will be the pH. So it's a very useful application for finding pH. Electron configuration is also another pretty important one. So we'll just say this will be atomic number 20, which will give you the electron configuration, so that is pretty helpful. Also gives you a guide on how to find the electron configuration through here, and then the element will be Ca. So this is a really helpful thing if you want to just do a general thing for AP Chem. We'll go into the next program. The next program will be buffers. Buffers is a pretty hard unit for all those that know. So all you do is just plug in your rate constant, and we'll just say that is 0.25 from the last example. Your A, we'll just say the concentration is 3.0. Second, -3. B, we'll just say is 1. And that will be the pH of the buffer, or pOH. So it's pretty helpful for finding all buffers. Next, we'll go into calories or calorimeters. So you just have to plug into X. These are all your heat equations. So we'll just start off with MCAT, the most important one. Q, we'll just say that is blank, so we'll put that's for X. Mass, we'll do 6 grams. We'll just say it's water, so 4.18. And the delta T will be 8. And then that will be your heat. So it's a pretty helpful equation for those that want to find out what the heat of a reaction is. This one essentially the same thing. We'll just plug in A for that. Moles, we'll just do 2. So it's the same thing. It just uses all of the equations that you are given from the test, but if you just want to plug it in and find out what the answer is, you can do that. For enthalpy, we'll just do same equation here. We'll just say the initial temp is 24 and it went up by 5, so that'd be 29 degrees, and that's your delta T. So it's a pretty easy equation to use. We can go on to the next program. Combustion reactions, it's pretty easy. You can just say how much grams you're putting in, so we'll just say it's a 9-gram sample, and there are 5 grams of carbon dioxide and 7 grams of water. And this is essentially just saying what is the molar mass of the sample, so we'll just say the molar mass is 41 grams. And then this will be how many moles of your carbons, hydrogens, and moles of your sample that you are trying to do. This is the empirical formula for what we're trying to figure out, so be CH27 X and then whatever your sample is. And then you can essentially just find whatever molecule. So molar mass we'll say is 41. We'll just say it's 67. I'm not sure what it actually. Okay, we'll just discard that. We'll go into our next program, which will be compounds. Sorry, concentration. So how many moles of the solute is there? We'll say 6 moles. How many liters of water are you dissolving it into? So we'll say 7. And this is the molarity of that. So it's pretty easy if you just want to find out what the molarity of a solution is. And you all know that you can do moles over liters to find it out. So it's essentially just plugging in numbers so you don't have to really think about it that much if you're under stress in the AP test. So it's pretty helpful. We'll go and quit out of that and go into our next program. And all these other programs are just things for math, so I've used this calculator for other things, not just AP Chem. We'll go into the free energy, Gibbs free energy, so we'll just say the H of a thing is 6, the temperature will be 7, and we'll go and say the entropy is 9, and then this is what G will be, which we all know if G is negative, this will be thermodynamically favored, so this will be a thermodynamically favored equation. So it's pretty helpful just for those that don't want to work and do the solution just by itself. You can just plug in the numbers and go with it, so it's really helpful. We'll quit out of this one and go into our next program. Half-life. Half-life is a pretty easy one, so we'll just say we'll go into formulas just to see what there is. So you have this, which is just essentially the half-life formula. Original mass times by 0.5 because it's a half-life by the number of half-lives there are. And to find the number of half-lives is just total time divided by the half-time. So you can get these, whatever the problem gives you, you can find out hopefully what the final mass of a solution will be. So now we can go that. We'll go and solve for the original mass. So we'll say the final mass is 9 grams. The half-life is 3.24 because I know that's the common one. Total time will be, let's just say 10 minutes. So this was what the original mass is, what the amount of half-lives there are. So it's really helpful for finding out any of these two variables, along with if you want to do it in reverse to solve for the final time. We'll just say what the half-life is 3.24. Total time is 6, and original mass is 9. Amount of half-lives and the final mass. So it's really helpful for solving what all that is. I didn't have to use it at all during the AP test, so that was good, but you can still use it if need be. We'll go in and do moles, which is a pretty easy one. It gives you all the conversions, so grams to moles to grams, moles to atoms, or atoms to moles, which we all know we can just use Avogadro's number for that, or just the molar mass for these, but you can just plug whatever it is. So we'll say there's 8 grams, and the atomic weight is 41. That's the amount of moles. Really simple calculation, not much. We'll go and do an atom solution. So we'll say there is 6 moles, boom, just like that. Really easy, pretty simple. We'll say there is 3.02 to 24th power. That's the amount of moles. Really simple and really easy. It just gives you a lot of simplicity on the AP exam, so you can focus on how to apply it, which is really helpful. Oh, I skipped over gas laws. This is one of the most important ones. I think there is all of the different gas laws that you can use. So we'll go in tri-Boyle's, which is pressure times volume equals pressure times volume again. So we'll say we're finding pressure. P1 will be 8 ATP and 6 liters going to 9 liters. That's the pressure of the second solution. Since we have the first one, we're trying to find the second one. That's the amount of atmospheres in that thing. We'll go ahead and do a different one with Charles' law. This one is volume and temperature. So say we'll find for temperature, the first volume will be 9 liters, let's say, with a 24 temperature. The second volume, we'll say it's decreasing, and that's the amount of temperature in the second one. So again, it's pretty intuitive. You just plug in the numbers and get what you need to get. We'll go in and quit out this one and go to a different program. We'll go to pH. This is a pretty important one. So it's the same thing as what we had earlier. If you have the number of ions of hydronium or hydroxide, sorry about that. We'll say we are trying to find out the pH, so we'll say there is 0.056, second E to -6. That's the concentration of hydronium ions. So this is whatever your pH is going to be, and that's going to be the hydronium concentration. And then if you hit enter again, that gives you the amount of hydroxide concentration. We'll say, well, we have the amount of hydronium concentration. We'll say this one is 6.08 to the -9th. That's going to be the pH and hydronium concentration. So it gives you all of the different concentrations or pH that you need. I'll go ahead and use a better example for this. We'll say the pH is 9. That's hydronium. That's hydroxide. Really simple to use, and it's very helpful because I had to use this one a ton on the AP test. We'll go ahead and do the last, but definitely not least, is the VSEPR. So this one is for geometrical shapes of a molecule. So based on a single bonds, angles shift a few degrees away from double and triple bonds. So this may not be accurate, but I had a question that related to single bonds and a triple bond on the test. So you can use this concept to find the answer to that, which was very helpful. So you want to find out how many atoms are bonded to the central atom. So we'll say there is 3 bonds attached to the central atom, and there is 1 lone pair. This will give you the amount of bonds, lone pairs that you put in. This is the amount of electron clouds you have. This is the hybridization, so sp3, with a shape of trigonal pyramid and a bond angle of 107. So it gives you all the information so you don't have to memorize any of this, which I use this one a ton as well, because it just gave me all the answers. So we'll just go ahead and do something else. We'll say there is one bond, linear, 180 degrees, with an hybrid of S. We'll do one more. We'll say there is 2 and 0. SP, linear, really helpful. 2 and 2. Hybridization of sp3, a bent shape with a bond angle of 104.5. So these are all the main important things that you could ever hope for on a calculator, and this is very beneficial to the AP test. Thank you.